We continue with the exercise 5.5, question numbers 3 and 4. Now third question. There are two set squares in your box. What are the measures of the angles formed at their corners? Do they have an angle measure that is common? There are two set squares in your instrument box. You can see two set squares in your instrument box. What are the measures of the angles formed at their corners? What are the measures of the angles formed at their corners? Now you can see the two set squares. And we have to look into the angles formed at their corners. Now this set square, we can say that it is a 45 degree, 90 degree set square. So the bigger one, we can say that 45 degree, 90 degree set square, and the angle formed at this corner, we can see that a square box, so it will indicate 90 degree, and the other two angles are 45 degree each. So the first set square, the angle measures or the angles at the corners are 45 degree, 90 degree. Now we have one more set square. So that set square, the angles are 30 degree, 60 degree, 90 degree. So the set square is a 30 degree, 60 degree, 90 degree set square, and the angle formed at this corner, it is a 90 degree, and the other two angles are 30 degree and 60 degree. Then, do they have an angle measure that is common? Now look at the measures. So which angle is common here? 90 degree. So do they have an angle measure that is common? Yes. So what is the common angle measure? 90 degree. So we can write yes, and the common angle measure is 90 degree. Now next question. Study the diagram. The line L is perpendicular to line M. Now look at this diagram. The line L is perpendicular to M. So you can see the line L and the line M, and the line L is perpendicular to line M. Then you can see the points. The points are marked on the line L. Now the first part of the question, is CE equal to EG? So the length of CE is equal to EG. You have to check. The length of CE is equal to EG. Now look at that. What is the length of CE? What is the length of CE? C is at 3, E is at 5. So what is the length of CE? CE is equal to 5 minus 3, that is 2 units. Then what is the length of EG? E is at 5, G is at 7. Therefore, what is the length of line segment EG? 7 minus 5, which is also equal to 2 units. Now, check whether CE equal to EG. Yes, we can say that CE, length of CE equal to length of EG. Now, second question. Does PE bisect CG? Does PE? So here we can see this as PE. Does PE bisect CG? PE. So E is the midpoint of a CG. You have to look into whether E is the midpoint of a CG. The point E divides CG into two equal parts. You have to check. The point E divides CG into two equal parts. So, if the point E divides CG into two equal parts, C will be equal to EG. Here we want to look into whether PE bisects CG, whether PE divides CG into two equal parts. So, if PE bisects CG into two equal parts, CE will be equal to EG. Now, we got the measures of CE as 2 units and EG as also 2 units, and we got our CE equal to EG. Therefore, what we can say that the line segment PE bisect CG. So, PE bisect CG. So, we can say that yes, PE bisects CG. PE bisects CG. Now, next one. Identify two line segments for which P is the perpendicular bisector. Identify any two line segments for which P is the perpendicular bisector. P is perpendicular to the given line segments. So, what is meant by perpendicular bisector? The line segment or line which divides the given line segment into two equal parts and as well as perpendicular to the given line. So, the angle formed between them is equal to 90 degree. So, you have to find out, it is already given line L is perpendicular to M. Therefore, the angle formed at here will be 90 degree. So, it is already perpendicular. Now, we want to check and we have to find out the perpendicular bisector. And we can see that P bisects CG. Therefore, P bisects the line L. P bisects the line L. Therefore, we have to find out any two line segments for which P is the perpendicular bisector. Now, we can look into that. Now, look at that D line segment DF. If P is the perpendicular bisector, D will be equal to EF. So, we can take one of the line segments as a D line segment DF. So, if you consider line segment DF, PE bisects DF into two equal parts, and we can say that D is equal to EF. So, what is the length of TE? 5 minus 4, 1 unit, and what is the length of EF? 6 minus 5, 1 units. So, the length of line segment DE and EF are equal. Therefore, we can say that P bisect DF. So, we got one line segment DF. Now, we have to find out another line segment also. Now, we already got PE bisect CG. We already got. Now, we have to find out one more. So, if you consider BH, the line segment BH. Now, if you consider the line segment BH, what is the length of B? B equal to 5 minus 2, that is equal to 3 units, and EH, E is at 5, H is at 8, 8 minus 5, 3 units. Therefore, EH is also equal to 3 units. So, if you consider the line segment BH, the BE is equal to EH. BE is equal to EH. So, we can consider the next line segment as a BH. So, we have to find out two line segments for which this P is the perpendicular bisector. So, first one is a DF, the line segment P is the perpendicular bisector. Next we can take it as CG, it is already given, we got it, and the next one we can take it as a BH. So, the answer is a DF, line segment DF and line segment BH. Now, next one. Are these true? We have to verify. Now first one, AC greater than FG. Length of line segment AC is greater than length of line segment FG. Now what is AC? First of all you find out what is AC. AC is equal to A is at 1, C is at 3. So what is the length of line segment AC? 3 minus 1, which is equal to 2 units. Then again FG, we have to find out FG. What is FG? F is at 6, G is at 7, 7 minus 6, which is equal to 1 unit. Now the question is whether AC, length of line segment AC is greater than FG. Now look at that, AC is 2 units, FG is 1 unit. Which one is greater? AC is greater. So length of AC is greater than length of FG. So we can say that it is a true. Now second one, CD equal to GH. CD, what is CD? CD equal to, CD means 4 minus 3, 1 unit, and GH, GH is equal to, G is at 7, H is at 8, 8 minus 7, that is also 1 unit. Now whether CD is equal to GH? Yes, so that is also true. Now next, third one, BC, length of BC less than length of EH. So we have to find out BC. What is the length of line segment BC? BC means B is at 2, C is at 3. So 3 minus 2, you will get it as a 1 unit. Then EH, E is at 5, H is at 8. Therefore, EH is equal to 8 minus 5, which is equal to 3 units. Now look at that. BC less than EH. Length of line segment BC is length of line segment EH. So BC is 1 unit, EH is 3 unit. Therefore, we can say that length of BC is less than EH. So this one is also a true statement. So all the 3 statements are true. So that's all for today's class. Thank you.